Good afternoon, students. We'll start the class. And in today's class, we are going to discuss about the concept of web and HTTP. So we all are using the web applications in every day of our life, right? And HTTP is the known protocol, well-known protocol that is used. And this HTTP protocol uses the port number 80, right? So the port number for the hypertext transfer protocol, which is operating the web, is 80, right? And he's the one who developed the first web browser, and he's the one pioneer of developing this web application, Tim Berners-Lee. Okay, so and this is the first web page that was created. So before the inventions, earlier days, the web application was used primarily for transferring the files between the universities, but then it was open up to everybody for downloading the pages from the server that they want and use for few applications. And this was the first web browser that was invented. And now the primary principle on web is web operates on demand, right? So on demand in the sense, whenever we want any content, then the web provides the content to us, right? So whenever user receives what they want and when they want it. And HTTP is the heart of the web, right? Hypertext Transfer Protocol is the one which defines the structure for how the client has to talk to the server and how the server will communicate to the client. So this is the primary protocol over which the web applications that we use in our everyday life works, right? And let me introduce you to few of the web terminologies. Okay. So the first terminology is web page. So most of these terminologies is well known to you, but yet we'll just quickly go through it before we dive into the concepts of HTTP and web. Right. So the web page is, you know that you will just provide a URL in the browser. Okay. And as soon as you provide a URL, immediately a page is loaded from the server to the client machine. So that is what you called as a web page, right? And most of the web pages are built using the protocol or using the language HTML, right? So the markup language HTML is used, or that is a foundation for every web pages. And all these web pages are stored in a server, that is usually we call it as a web server. Nowadays these web servers are maintained in the name of something called as a cloud or data center, right? And the web browser is an application that is running on the client side. So if suppose I want to talk to a web server, I'm supposed to use the web browser. And you this is a client server based application. There are two network architectures. One is a client server architecture where the client will ask for the request and then the server will provide the reply. Okay, and the second one is a P2P architecture where everybody else can communicate among themselves to serve this application. And this is a protocol, or this is an application which cannot tolerate losses, right? And so it seek the help of TCP, the transport layer TCP. And the TCP uses the reliable data transfer concept, the connection establishment, the sequence number, acknowledgement number is also used for this. And one competitor or the opponent for TCP is a UDP, which uses unreliable data transmission or the best effort delivery. And HTTP, the protocol that is used. So these are some of the key protocols. And this HTTP is a stateless protocol. What is a stateless protocol? The server doesn't bother about what is the state of yours. It does not maintain any detail of yours. What is that you are, which state you are in. Okay, so whenever you do a communication, so it does not bother about it. Okay, so the HTTP, especially the HTTP protocol, does not maintain any information about the user on its side. So that's why it is called as the stateless protocol. So now I told you that web is a protocol which requires reliable data delivery. There should not be any packet loss. And so it operates over the reliable transport layer called TCP. Now, how actually the web works is what we will see in the few slides. Now, initially, what happens is whenever you type a URL or you go to Google and you type what are the favorite books in networking, or what is the weather in Coimbatore now. And if you are typing some request, and what happens is initially a hi message is sent from the client to the server. So now the server will respond to this hi message saying hi client. So as we discussed in the class, there are three-way handshaking that takes place between a client and a server. And the last message is the again an acknowledgement message from the client saying that connection open. So now both the client and the server are in a state where they are listening to each other. Okay, so and the client is available for the server and the server is available for the client. So they are in a state where both of them are listening to each other. So only after the confirmation of these three steps, the data transfer takes place between the client and the server. So the client and the server are engaged in the data transfer. And once the data transfer is done, once if the client has completed requesting the pages and the server has completed giving all its pages to the client, the last step called the connection close phase take place. So connection close phase is they are disconnected for that particular session. Okay, so for that data transmission session, they are disconnected. Is what these are the steps that takes place whenever you access a web page. So at the back end, there is a connection establishment that is taking place, and then the connection close that is taking place. And this is handled by the well-known transport protocol called TCP. So based on this TCP connection establishment, data transfer, and then you have something called connection close, your HTTP connection can be classified into two types. One is the non-persistent connection. The second one is the persistent connection. So now we'll see what is that non-persistent and persistent. So we all know that in a web page, there are a lot of objects. So there may be text messages, there may be images, there may be hyperlinks where you will click and go to the other pages. There may be advertisements, there may be many applets running. So there are many objects in your web pages, right? So in a non-persistent connection, how it operates is initially there is a connection open. All right, so initially there will be a connection open, and then what happens is the data transfer takes place. So maybe this is a an object. Okay, you imagine that the first objects get downloaded from the server side to the sender side, or from the receiver side to the sender side, and then immediately the connection is closed. Okay, and then again the connection is open, then the data transmission takes place and the connection is closed, right? So here what happens, what is non-persistent connection? So from this slide it is understood that the non-persistent connection is for the operation or for the downloading and uploading of every object, there is a connection open and connection close, right? So connection open takes place first, and then the data transmission of an object one, connection close. Then again the connection open, data transmission of an object, and the connection close. Now if you examine the time taken to fetch a file from the server, so there is a TCP has three-way handshaking, right? We all know TCP has three-way handshaking. So now initially a client sent a hi, then a server sent a hi, and then you have the final acknowledgement from the client, which is accompanied by the HTTP request, and then the server response. So it is 2 RTT for every data transfer. So maybe the time taken to fetch one object may be 2 RTT plus the file transfer time of that object, right? So for every object fetching, you have 2 RTTs plus 1 file transfer. So please remember this. This is a non-persistent connection. Now, what is its persistent connection, right? So persistent connection is nothing but you will have one connection open. All right. So initially there is one connection open, and then multiple objects are transferred. So between the client and the server, the objects are transferred, and then you have the connection close. So usually the connection close happens after downloading all the objects in your web pages. That is how it happens now. Okay, in all your browsing applications. Okay, whenever you browse a page, maybe a cisco.com or amazon.com or ebay.com or so whatever it is, whatever web page you give, so initially a connection is closed, that open, a TCP connection is open, and then that a connection is closed. Okay, and The default mode of HTTP uses the persistent connection with pipelining. Now, if you examine the time taken here, so this phase takes place in 1 RTT. Again, here is a file transfer time and file transfer time, and the last one takes place with RTT. So the time is saved here by means of the one connection open and one connection close, right? So compared to non-persistent, you will have an efficient management of time in the persistent connection, which is used nowadays by the web application. Now moving on to the message format, whenever the HTTP, it's a client server application, right? So HTTP is a client server application. You have a client, then you have a server. So whenever a web URL is typed in your browser, the client sent a request from the client to the server, and then the server gives you a response. So this request and response is having a format. Okay, only if you give according to a format, then the client server can understand, and only when the server responds to you in a format, a client can understand. So we'll see what is that request format and what is that response format. So how actually it takes place is, initially the user issues the URL. So as soon as you issue a URL, your packet is framed within something called a request packet. Okay, immediately the URL is taken and it is framed into a request message. Now this request message comes to the server. The server will check for the particular web page in its database, and it just frames the response message. Okay, so it frames as a response message, and then the response message comes to the client. Okay, so a request message is framed in the transmitter side, then a response message is framed in the receiver side. So what are the content in a request message is what we are going to discuss first. So in a request message, the primary content is, you will have something called a method. All right. So what are the famous methods used in the HTTP is get method. The first one is get method. So whenever you use a get method, it means that you are going to fetch certain information from the server. Okay, so you are going to download some information or fetch some information from the server. So head is, whenever you use a method head, it means that you need some information about the server, not data. Okay, so but some information, maybe what is the version of a server, what is an operating system of a server. Okay, so some pre-functions or pre-information is what you want from the server. The next one is post. Okay, so post is whenever you fill a form. Okay, you are filling a form. In that case, you will use a method called post. So post means you want to submit some data to the server. Next, put is, usually put is used whenever you upload a file. Okay, so whenever you want to save a file, you will attach a file and you will send it, right? So whenever you want to save an object, you will use the put method. And the last, delete method, is used whenever you want to delete an object. So you don't know no more you want that page in the server. So in that case, you can use the delete method. So the first message you will have is the method. All right, so it is accompanied by the HTTP protocol and the version. Okay, so it is accompanied by the protocol and the version, and then it will have the browser type that you are using. Okay, so Mozilla is the browser that you are using, Firefox is used, and what is its version. Then what is the application? This text HTML is an application, and what are the accepted languages? Okay, so any languages that is accepted is used, right? Accepted languages. And what are the encoding method? Okay, an encoding method, and the content length, right? So all these informations are sent. Okay, so this is a post method. And what about the get method? Again, the get method, and it is telling that you go and get this particular URL, index.html. I want index.html, and this is the protocol and its version, and where I should go and get it. I should go and get it in this particular web page, nowhere123.com. And what are the accepted format I have? These are the accepted format. English, US English is accepted language, and the user agent, that is I'm giving this request from the Mozilla Firefox. All right, I'm using this from the Mozilla Firefox. So these are the content of the request messages. So it will have a methods. Now, what will be the content of the response, right? So now the server will respond. So what are the content of a responses? So it will have the protocol and its version, okay, and then it will have something called a status code. This is called status code. So what is a status code? There are different status codes available. So the first status code is 200 OK, means okay, everything is done. The particular file that you are requesting is just getting downloaded. And then 201 created. So mostly you would have seen 200 OK, right? So if your request is successful, you will get 200 OK. And you might have also seen 301 move permanently. If that page, if you have given a wrong web page or old web URL, then you will get it is moved permanently. All right. Then you will get a message called 404 not found. So mostly we might have seen 404 not found. And then we might have also seen 403 forbidden, right? So if you are accessing some forbidden content, then 401 unauthorized. Okay, so if you are accessing with the wrong certificate or wrong authentication, you will get unauthorized. And 400 bad requests. So these are few codes that we have seen. All right, and service unavailable also. So mostly if the server is down, then you will get a message 503 service unavailable. And then the date and time of the response. So here it is Sunday and the time of the response. And what is the version of the server? This is Apache server, right? And when was that content last modified? So the content was updated. The content that you have requested was updated 20 November 2004. Okay, then accepted range, what is its size, what is the content type, all right? Then the content following by the application data. So this is where the data is, the particular pages, right? So that page is downloaded from the server to the client. All right. So this is the format of the request message and the response message of HTTP. So all the time starting from 1990, the time of its evolution, it is being updated, and now the HTTP 2, then HTTP 3 has come, okay, which is very compatible for the low memory devices. Okay, so there are few devices which has less memory, less energy constraints. So for such devices, the HTTP 3 has come, right? And what is the difference between HTTP 1 and 1.1, which is very widely used, is they have 16 status code, here 24 status codes. Here only basic authentication is there in HTTP 1.0, but here you have the strong authentication, all right? And it uses a non-persistent connection, which is consuming so much of time. It uses a persistent connection where there is only one connection open and connection closed for downloading all the objects. So these are the different methods between, or difference between 1 and 1.1. Now, what is the difference between 1.1 and 2? So the difference between 1.1 and 2 is well explained in this diagram, right? So you can just go to this URL to understand. They have on real time, they have tested 1.1 and 2. So they implement the concept of pipelining. Okay, so instead of getting you everything on a connection open, you will get everything at a stretch using the concept of pipelining, which still consumes or which still saves more time. Okay, so now you see, whenever you put a URL in a web browser, in a flick of second, you get the response. So how you were able to get it? Because of the concept of a persistent connection and pipelining, right? So next, the very important concept that is utilized in the web is the cookies, right? So in every of your web browsers, the cookies are done. Now, what is a cookies? The cookies allows the site to keep track of the users, right? So there are four main components of the cookies. So cookies in the request message, cookies in the response message, cookies managed by in the browser side, and cookies managed in the server side. So whenever you request anything, immediately the server will allocate a number to identify you, and every time it send a response, it will send accompanying that particular number. So whenever the next time the HTTP request sent, it is sent along with that particular ID. Okay, so this is a cookies maintained in the user side. Okay, and then this is a cookies maintained in the request message. Now, how actually it works? We'll see how actually the cookies works. You all know about the function of cookies. So, initially, let's take the e-commerce application like eBay or Amazon, right? So, for the first time, whenever I send a request message, the server will create an ID for me. Okay, the server will create an ID for the user, and it will send a response saying that set cookies to 1678. So it is asking the client to record the cookies of 1678. Right. So I type www.amazon.com. So server creates 168 and it enters at the backend also. Okay, so client C1, I have the ID as 1678. Right. And it sends that to the client side. Now, what the client will do is the client will also store it in its database, right? So after that, when it sent a request, it is sending along with your cookies. Okay, so 1678. Now, cookie specific action, okay, is taken in the database. So, for example, what is your browsing history? All right, which is the most liked product by you, or what is your order history? Okay, so all these details are stored there. Maybe 1 week later, you go and visit that particular website, amazon.com. So now what happens is all your browsing history is maintained. Okay, so a copy of it is also maintained in your client side, and the detailed report of it is maintained in the server side. So now, whenever you go, it is comparing that with the cookies that is stored at the backend, and it is fetching. Okay, oh, the last time when this user has visited, she has browsed for a mobile phone. So let me just load all the pages related to a mobile phone first. Okay, so or all the offers related to a mobile phone, or any hot sales that's going on related to a mobile phone. So based on your cookie data, your data is analyzed and a particular response is given to the client. So cookies is something that store your browsing information, all right, in the client side as well as in the server side. All right. Now, let's go to the next concept called web caching. So, why is web caching important in the network, and what is the use of web caching is what we will discuss now, right? So, what is web caching? For the first time, when a client requests for a message, all right, it goes to the internet, okay, and then it goes to the server. The server gives the page back to the internet, and it comes to the network through the networking devices, it comes to the client. Now, what happens is there is always a local web server maintained in every organization. All right. So, a copy of that message is stored in your local server, local web server, so that the next time when the client requests for the page, right? So, and the is not routed to the server, but it comes straight away to your local web server, and the data is fetched from there, and the response is given to the client. So now the web caching will improve your timing. Okay, so or it will reduce your timing delays. Okay, between your request and the response. So every organization will have a well maintained server which will catch your pages and the recent pages, especially your recent browsing pages, and immediately it fetches and give it to you. Right now, let us take here to a simple example to illustrate the importance of web caching. Okay, say for example, this is an institutional network. All right, so please follow it up. Okay, this is an institutional network with the 100 Mbps LAN. All right, so 100 Mbps LAN, and there is a link. Okay, there is a access link which with 15 Mbps, which is connected to the public internet. So imagine this is our university network, and the inside the university we are using the data speed of 100 Mbps, and our university say we are connected to the internet service provider through 15 Mbps access link. Now we'll calculate the delay, all right, the traffic intensity. We know the formula for traffic intensity is LA by R. So say I want to fetch a file of length 1 megabits, all right, and the request rate is 15 requests per second because let's say the arrival rate. Okay, so every second at least this particular network is handling 15 requests. So L is 1 megabits, A is 15, and R is 100 Mbps. Inside my institution network, it is 100 Mbps. So the traffic intensity is LA by R. So 1 mega into 15 is the arrival time divided by 100 mega. So mega and mega get cancelled. So I get 0.15. So we saw when we discuss about the traffic intensity, we saw that Li by R should be less than 1. If it is less than 1, it means that LA, the traffic intensity, is less than the data rate R, where your network is very well prepared to handle your data, right? So this is good. Inside your institutional network, it is good. Your it will be able to fetch your file of 1 megabits. Even though the request rate is 15 per second, you will be able to achieve it. But now consider the case of access link. So L is 1 mega, arrival is 15, and the data rate is 15 Mbps. Okay. Instead of 100, it is 15 Mbps. So the traffic intensity is 1 M into 15 divided by 15 M. So now the traffic intensity is 1, which is LA equal to R. It's a bottleneck condition, right? It is going in hand. The traffic intensity is exactly equal to the data rate. Suppose if the traffic intensity increases, this data rate may not be able to handle it, right? Now, how web caching is helping us? What can be the possible solution to accommodate this problem? Because you have the traffic intensity as a bottleneck, hand in hand. The traffic inside your network or the traffic leaving your network was exactly the same as per your access link. How can you handle this as a network administrator? One thing is you increase this particular access link, you increase it. But do you think that will be a possible solution for it? Because that may not be a possible solution, because it is a long time solution and it is a cost effective solution also. Okay, it involves cost, it involves getting a lot of approvals, protocols, and all such things follows for a long time solution. Now, the second best solution can be web caching. Okay, so you can introduce a concept of web caching. Say, I have a local web server. Okay, so all of you see this particular picture. So I maintain a local web server where the web server is able to handle 40 percentage of my internet traffic. So 40 percentage of my data that I ask for is coming from a local server itself. Now what happens is, already my traffic rate is 1, but this time not every traffic is moving on. Only 60 percentage of my traffic is going out. Okay, that is 1 into zero point 0.6, which is 0.6. Only 60 percentage of that 15 Mbps is used. This 15 Mbps, only 60 percentage is used for my purpose, and remaining 40 percentage I was able to save because I am getting those content from my local institutional web server itself. So this way the web caching could be good in helping us to maintain the access link without going for a high cost solution, right? So this is one advantage, or this is the importance of having the web caching, right? And now the question is, uh, whenever you go for a web caching like application, what about the content? Will it be updated, right? Will it be updated, or how can I ensure that I'll get an updated content? Okay, so there is also a method called conditional get. Okay, so this allows the HTTP to verify the validity of the web objects. Okay, now how actually it works, we'll see with this example. So for the first time, the client is requesting some content to the server. Now the server is responding. Okay, so responding to the content. And the next time when I ask, okay, so to the server, all right, I just ask the server, maybe a week later or something, I ask, if modified, okay, since September 11, September 7, 2011. If your content is modified after this, if you have an updated content, any update, if your content is not up to the mark of this date, so you have to tell me. Now it is asking, 1 week later it is asking for the same content. Now it has not updated, the server has not updated anything. Okay, it was still the old one, or there is no updation done. Then it is responding not modified, 304 not modified, and it is returning an empty header. it is returning a empty header to the client. Okay, what does it mean? It means that it is not modified. Okay, so that is about the web and terminologies. So in this lecture, we saw about the web terminologies. We saw about the non-persistent connection, which is using connection open and close for every downloading of its object, but persistent, which is not using connection open and close. Instead, it is using connection open and close for all the objects together. Then we saw about the message formats. Message formats is the very important is in a request message, we have the methods, and in the response message, we have the status codes, right? And then we saw about HTTP version where 1.0 is using non-persistent and 1.1 is using persistent and 2 is using persistent with pipelining and 3 which is defined for the energy constrained devices. And then we saw about cookies where the detail of the user browsing history is maintained in the client side as well as in the server side, and it is communicated back and forth for effective communication. Then we saw about web caching where a copy of your message is maintained in the local proxy so that it behaves like a web server whenever you access for a content, so the data can be delivered to the client very quickly. Then we discussed about conditional get where it talks about the modification of your data. If the data is not modified, then the data can be fetched from your local proxy itself. So we use conditional get and it is responded with 304 not modified. So these are the topics of discussion on HTTP and web.